Hello everybody and welcome back to Whiteboard Wednesdays with Vanna. It's our new season 5 and this is our first episode. And we thought we'd kick it off with a bang. So we're going to be talking about the new NVIDIA DGX quantum interface computer. So we're going to really just double down on some of this. Stick with me. Disclaimer, I'm not a quantum physicist or anything like that. What I'm talking about is obviously you can go check on the internet and make sure it's 100% right. But this is really a first for NVIDIA and what they're doing here, because effectively what they're doing is they're bridging the gap between classical computing and quantum computing. Now you're going, what is the difference between classical computing and quantum computing? That's probably a good question. So if we think about every single type of processor we've got today, we've got our CPUs, right? We've got our GPUs, we're very familiar with DPUs. All of these computers that make up our world today is what we refer to as classical computing, right? It uses effectively a binary format, right? Something can either be a 1 or a 0. So anything that uses binary in terms of how it processes its information is effectively under that classical computing area. Now, on the other side, what's the difference between that and quantum? Well, on quantum side, we effectively have a quantum processing unit, right? And if you want to go and have a look at what this looks like, just go Google Google's image, and we might actually put that up as well. But really what we've got here, this is what quantum computing is. And the difference here is that we're working not in binary, but in qubits, all right? Now, what is the difference between a qubit and a binary bit that is a state of 1 or 0? So, well, as we know, like a light switch, it can either be on or off. And that is a very simple way of how we relate to what is binary. The difference here is that in a qubit can be those two states at the very same time. So the light can be on and off at the same time. And the reason for this is that we're dealing with two completely different set of physics rules, right? Quantum mechanics versus our normal physics that we've got here. We're not going to go into that because that, it's just crazy. But what suffice to say is because those qubits can exist in two different states at the same time, it is a magnitude of order of more processing power that a quantum computer gives you. And that allows us to address really big data and big algorithmic problems, and allows us to solve those calculations a lot quicker. So to the point where you actually need a NVIDIA supercomputer to drive an interface to a quantum computer, and that is exactly what NVIDIA has done, and that's why it's so exciting. So they've released at the latest GTC the DGX Quantum, which is effectively a software package where we effectively can take CUDA package Quantum, which is an open source package that allows the classical world to be interconnected and interfaced into a quantum computer. And they're partnering with another crew called Quantum Machines, and Quantum Machines have a unit which is effectively a quantum computer, quantum controller, and that is the OPX controller. So effectively what we're doing is we're taking a DGX supercomputer, we're pairing it with the OPX, which is the quantum machine interface, and allows us now to bridge the gap between classical computing and quantum computing. First of its kind. Really interesting. Now, what's the benefits of this? Well, unless you're got the budget of a country in terms of science research, trying to get a quantum computer or quantum program stood up is quite significantly expensive. And then also these qubits are inherently unstable because of the way that they actually work. So one of the big things that they're looking to apply all of this for is to lower that entry level into building classical and integrating it into quantum computing technology, and to allow you to manage that pipeline of flow. So it's really lowering that threshold for introducing high performance computing, quantum level, into mainstream. And this is the first step that the world is taking into getting this right. Up until now, you either had to be in one world or the other, the classical world or in the quantum world. Whereas from today, it's possible to actually straddle both of those worlds. So really, really fascinating things. Applications for this is obviously AI, chemical or chemistry, highly mathematical problems that need to be solved in those areas. So the medical field, obviously, it's pretty much any large question that we as humanity have to answer, which quantum computing is going to hopefully give us answers to. So fascinating stuff from NVIDIA DGX Quantum with the CUDA Quantum software suite is what they've launched, and that they've partnered with a few guys who are basically doing interface work into those quantum platforms. So that was the first of the new releases at the new GTC from NVIDIA, and we're going to be looking at some others going forward. But keep an eye on this one, because it's going to be interesting for our future very, very shortly. Thank you very much for joining us at Whiteboard Wednesdays with Werner. Please don't forget to like, share, and follow our LinkedIn page.